Something is wrong with the early universe. The data does not match physics. No one knows what these things are. In nearly every image of the infant cosmos, small red dots stare back. Objects too massive, too bright, too old to exist at the dawn of time. What were they? And why did they vanish before the first galaxies finished forming? The light reaching you tonight is 13 billion years cold, a faint, bleeding red whisper from an age that should be empty. You look at the past expecting to see the seeds of the familiar. Instead, you see a cosmos that no longer exists. Right now, as you watch this, that red infection is still arriving. By the end of this, you will know what the red dots are. An infection of red. The telescope was built to see farther than any instrument in human history, farther than Hubble, farther than Spitzer, farther than every machine you've ever pointed at the sky combined. It took 32,000 hours of observation time since December 25th, 2021, and in that darkness, it found something that should not be there. They appeared first in the Eiger survey, then again in fresco, small red smudges in the deep field images, clustered between 500 million and 1 billion years after the Big Bang. At first, engineers thought they were artifacts, noise in the sensor, light leaking through a seal, cosmic rays hitting the detector at unlucky angles. But the smudges persisted. They showed up in different surveys, different instruments, different quadrants of the sky. By March 2024, astronomer Jorrit Matthey published the first systematic catalog. He gave them coordinates, redshift values, brightness curves. He turned a photographic quirk into a physics problem, and the problem had no name. These objects are compact, under 500 light-years across. You could fit one inside a single spiral arm of the Milky Way, but they burn with a brightness that defies their size, radiating energy as if something inside them is consuming itself faster than the laws of thermodynamics should allow. Their light is shifted so far into the red spectrum that Hubble never saw them. They were always there, hidden beneath the threshold of every telescope you ever built. And then, 1.5 billion years later, they vanish. Not dimmed, not scattered, gone. You are looking at a population of objects that flood the infant universe and then disappear from the archaeological record entirely, as if they were erased. The redness wasn't an accident of distance. That realization arrived slowly, like a stain spreading across clean data. You measure light from objects 13 billion years away, and you expect cosmological redshift, the universe stretching wavelengths into crimson as space itself expands. But these objects carried something else. Something intrinsic, a redness that defied the simple geometry of expansion. The first explanation felt comforting: dust. Interstellar dust reddens light the way Earth's atmosphere turns sunsets orange, scattering away the blue, leaving only the warm tones behind. If these objects were shrouded in thick clouds of cosmic particles, their light would arrive tinted, distorted, but ultimately explainable. For a brief moment, the mystery seemed to collapse into textbook astrophysics. Then JWST's near-infrared spectrograph tore that comfort apart. The spectrum wasn't just red, it was wrong. A V-shaped distribution, emissions spiking high in the blue and ultraviolet on one end, spiking again in the red and infrared on the other, with a deep, inexplicable trough carved through the middle. No known object produces this signature. Not stars, not galaxies, not quasars. It was a fingerprint that belonged to two different suspects at once. But buried in that chaos, one feature stood sharp and undeniable: an absorption line at 364.6 nanometers, the Balmer break, the unmistakable mark of massive amounts of hot hydrogen gas, the raw fuel that ignites when stars are born. This wasn't random noise. This was a signature of stellar nurseries, of regions where gravity crushes gas into fusion, where light fights its way out of dense cocoons of matter. The hypothesis snapped into focus: starburst galaxies. Violent, chaotic factories where hundreds, sometimes thousands of stars ignite within impossibly small volumes, their light choked by the same dust clouds that birthed them. Dense, dusty. Extreme, yes, but not impossible. The evidence lined up. The spectrum suggested youth. The redness suggested shrouds. The Balmer break confirmed fuel. For a moment, the detective thought the case was closed. But in astrophysics, a single fingerprint is never enough, because the universe doesn't care if your answer makes sense. Right now, as you watch this, that same spectrum is still arriving at Earth, carrying information that hasn't changed in over 13 billion years. And the more scientists examined it, the more they realized the fingerprint didn't just belong to two people. It belonged to no one at all. The answer seemed to arrive with the clarity of a solved equation. Starburst galaxies, dense clusters of newborn stars, wrapped in thick clouds of dust that redden their light like smoke filtering the sun. The model was elegant. It explained the brightness, the color, the Balmer break. Every observation locked into place. For a brief moment, the universe had been reasonable. But when Caitlin Casey's team ran the numbers, the equation returned a result that should not exist. The stars detected by the James Webb Space Telescope could only produce enough heat to create 1% of the dust observed. Not a small discrepancy, not a rounding error, a shortfall of 2 orders of magnitude, 100 times too little matter to explain what was already there. You cannot build a mountain from a handful of sand. You cannot redden light with dust that does not exist. The model collapsed. And the collapse revealed something worse. To generate the necessary dust, stars would need to pack so densely that they'd orbit only a few astronomical units apart, closer than Earth is to the Sun. At that density, gravity becomes a vice. Stars would collide, constantly. The system would tear itself apart in cosmic violence, radiating X-rays, shredding into chaos within a few million years. But these objects had existed for billions of years, stable, silent, impossible. And when Webb's instruments resolved them at maximum magnification, they appeared not as galaxies at all, but as dimensionless points of light. No structure, no spiral arms, no distributed glow. A single dominant engine at the center of each, not a galaxy of stars. A second answer emerged from the wreckage. A supermassive black hole, feeding. Its accretion disk hidden behind a thick torus of dust, explaining the redness, the point source nature, the terrifying brightness. This model too was elegant. This model too fit the data. Until it didn't. Active black holes scream in X-rays. The superheated gas spiraling into oblivion emits radiation so violent it can be detected across the entire observable universe. Every known accreting black hole announces itself this way. These objects emitted none. Not a black hole either. The answer arrived in 2008, buried in the pages of the monthly notices of the Royal Astronomical Society. Hidden inside a paper few people read and fewer understood. Mitchell Beagleman, working alone with the mathematics of accretion and collapse, proposed something that shouldn't exist, a black hole star. Not a star powered by fusion in its core, not a black hole radiating its presence through X-rays, but a synthesis of both. A temporary hybrid born in conditions so extreme the universe only permitted them once. Here is what you're looking at. At the center, a supermassive black hole, already millions of times the mass of the Sun, accreting matter at rates that defy every limit known to normal astrophysics. Around it, not empty space, not an accretion disk, but a vast, bloated envelope of hydrogen gas, so dense, so thick, that it swallows every photon the black hole tries to emit. The X-rays that should announce the black hole's presence never escape. They scatter, they collide, they degrade into longer wavelengths, into red light. The gas is not static, it churns, It orbits at different velocities across layers spanning distances larger than entire solar systems. Every emission line broadens, not because the black hole is impossibly massive, but because you're watching a storm of motion, a photon-scattering envelope so vast it distorts every spectral signature into something unrecognizable. This is why SDSS J0100 plus 2802 looked the way it did. Not dust, not motion. A star wrapped around a black hole, or a black hole dressed in the corpse of a star it hasn't finished consuming. Those little red dots you saw at the beginning, the ones that shouldn't have existed, the ones that broke the models, they weren't cosmic accidents, they were larvae. The black hole star doesn't last. It can't. The radiation pressure from the black hole at its core eventually overpowers the gravity of the surrounding gas envelope, and the shell is blown away. What's left behind is a naked, supermassive black hole, already formed, already feeding, already ancient by the time the universe learns what stars are supposed to look like. This is why they vanished after 1.5 billion years, not because the universe changed, but because they transformed. The fossil you thought was dormant, molted. And the problem you couldn't solve, the impossibility of supermassive black holes appearing too early, growing too fast, bypassing every limit the equations impose, suddenly has an answer that doesn't require miracles. It requires monsters with a childhood. Right now, in the deepest archives of telescope data, there may be more of them, misidentified, filed under stellar anomaly, waiting for someone to realize what they're looking at isn't a star that failed, but a predator that succeeded. You began by seeing inexplicable dots on a screen. You end by seeing the birth of the voids at the heart of every galaxy. So here's the question that remains, unanswered, suspended in the cold. If these objects never became stars first, if they collapsed directly from primordial gas into black holes, without ignition, without light, without warning, how many of them are still out there, hidden in the darkness between the dots, waiting to be named?